Assalamu alaikum wa rahmatullahi wa barakatuhu. How are you, student? Hope you all will be fine and studying well. Welcome you all the students for our chemistry lecture. As we have started modern periodic table, this is our 7th lecture for the same. Today, as we know, in modern periodic table there are 7 periods and 18 groups, as well as there are 4 blocks. Till our previous lecture we have studied electronic configuration of elements in periods. Today we are moving forwards towards electronic configuration of elements in groups. As we know, there are 18 groups. So the rule for writing down the electronic configuration for each groups are different. Let's move forwards towards electronic configuration of elements in groups. As we know, in groups, a new shell is added down a group. Fine. As the first elements of the group belongs to first period, it contain one number of shell. Second element of the same group will containing two number of shell. Third element 3 shell. So as we move down the group successively, each elements will containing a new shell in it. So a new shell is added down a group. The general outer electronic configuration. What is the general outer electronic configuration? Therefore, is expected to be the same down any particular group. Whatever group we are going down, as we are moving in the first group, the general electronic configuration will be same in any of the group. Either you take first group, second group, third group. We will see each and every group, inshallah. Okay. Indeed, it is found to be so for the group 1, 2 and 3. Here the figure 7.2 and table 7.1 we are going to show later onwards. First look over here. We will see the figure and table as well. So in the group 1, 2 and 3, it is found to be so for. Okay, it is same for 1, 2 and 3, that it is same down, the general electronic configuration is same down the group. While in the group 13 to 18, the appropriate inner DNF subshells are completely filled. Suppose the number of shell here it is 5. In any of the element it's belongs to 5th period and it belongs to 13 group. It containing 5 number of shell. Inner shell containing DNF subshell, there the electrons are completely filled. Fine. In which group? In group 13 to 18. And the general outer electronic configuration is same down the group. Here also the general outer electronic configuration will be same down the group, either for 13, 14, 15, 17 or 18. For this also we are supposed to see the figure 7.2 and table 7.1. So here student we have seen for group 1, 2 and 3 that the general electronic configuration is same down any group. While for the group 13 to 18, the inner DNF subshell are completely filled and the general outer electronic configuration is the same down the group. So here we have completed for group 1, 2 and 3 and 13 to 18. While for the group 4 to 12, the DNF subshell are introduced at a later stage. It has been DNF subshell, inner shell. DNF subshell are introduced at a later stage. 4 period for D, 6 period for F. Down the group. So here, due to this, variation in the general outer electronic configuration is introduced. There is little bit variation in the general outer electronic configuration only at the later stage for the group 4 to 12 as we are moving downside. So your student for 4 to 12 that D and F subshell, while in 13 to 18 you are saying that the D and F subshell are completely filled, while here D and F subshell are introduced at a later stage down the group. So there is a variation in the general outer electronic configuration at the later stage down the group 4 to 12. Here you see student group 1 hydrogen is there. As we know, hydrogen is now its atomic number is 1. Okay, fine. Its electronic configuration is 1s1. Fine. In group 1 you see lithium, sodium, potassium. Here as we are moving downside, here let's see for group 1 elements. Here the element's name has been given, its symbol has been given, and electronic configuration has also been given. Lithium symbol is Li, sodium symbol is Ne, potassium K, rubidium Rb, cesium Cs, francium Fa. Here the electronic configuration for lithium is 1s2, 2s1, as the atomic number for lithium is 3. For sodium 1s2, 2s2, 2p6, 3s1. This lithium belongs to second period, so it contains, these all are the elements of the first group. Remember student, these all are the elements of first group. Lithium belongs to second period, sodium third, potassium 4, rubidium 5, cesium 6, francium 7. So here you see, as per the rule of the electronic configuration of group 1 elements, the shells will increases, and the general outer electronic configuration, what is the outer shell? In the first element it is 2s, in the third it is 3s, in the fourth it is 4s, in the fifth it is 5s, in the sixth it is 6s, while in the seventh period it is 7s. So the general outer electronic configuration, that is your large shell, outermost shell, it is ns raised to 1. Why I am saying n? N is the number of shell. For the lithium, n is 2. For sodium, it is the last shell, it is 3. Potassium 4, rubidium 5, cesium 6, and francium 7. As you see, the general outer electronic configuration for group 1 is same, ns raised to 1. So lithium atomic number 3, its electronic configuration is 1s2, 2s1. Sodium 1s2, 2s2, 2p6. Then outer electronic configuration 3s1. Fine. Potassium 1s2, 2s2, 2p6, 3s2, 3p6, 4s1. Here again for ns raised to 1 it comes. Rubidium 1s2, 2s2, 2p6, 3s2, 3p6, 3d10, 4s2, 4p6, 5s1. Right? Cesium 1s2, 2s2, 2p6, 3s2, 3p6, 3d10, 4s2, 4p6, 4d10, 5s2, 5p6, 6s1. Or you can write the condensed electronic configuration of cesium Se, that is xenon, noble gas element. Xenon, then 6s1. Similarly, here also for francium, we have written the condensed electronic configuration radon Rn7s1. In this way, you are going to write down the electronic configuration of group 1 element. Fine. Let's see here, student. Lithium, sodium, potassium, rubidium, cesium, francium. Fine. For this group 1 element. Now for group 2 element, beryllium, Pe, belongs to group 2 and second period. Magnesium, group 2 third period. Ca, calcium, group 2 fourth period, and so on. So like this way, for group 2 elements, the rule is also same as it is for group 1 elements, that the general outer electronic configuration will be same. So for beryllium, 1s2, 2s2. Magnesium, 3s2, 1s2, 2s2, 2p6, 3s2. As you see the general outer electronic configuration, for beryllium it is 2s2. For magnesium it is 3s2. Calcium it is 4s2. Strontium it is 5s2. Barium it is 6s2. Radium it is 7s2. Fine. So here student, that for as in the group 1 elements, the general outer electronic configuration is same. Similarly, for group 2 elements, the general outer electronic configuration will be same. For beryllium, the electronic configuration is 1s2, 2s2. Magnesium 1s2, 2s2, 2p6, 3s2. Calcium 1s2, 2s2, 2p6, 3s2, 3p6, 4s2. Strontium 1s2, 2s2, 2p6, 3s2, 3p6, 3d10, 4s2, 4p6, 5s2. Barium 1s2, 2s2, 2p6, 3s2, 3p6, 3d10, 4s2, 4p6. 4d10, 5s2, 5p6 is s2. Or the condensed electronic configuration is xenon 6s2. For radium, Rn radon, okay, 7s2. In this way, we are going to write down the electronic configuration of the elements. As earlier we have studied Obve principle, we are writing down the electronic configuration of any of the elements based on the Obve principle. If you know Obve principle, it is very easy for you to write down the electronic configuration of any of the elements in the modern periodic table. So here student, first group, second group, third group, 4th, 5th, 6th, 7th, 7 till 12, then 13 to 18. So let's see here student, figure 7.2. We have seen the figure 7.2, and then first group, second group, third group. As you see, for first group, second group, and third group, the general outer electronic configuration is same. Fine. As we have studied the rule for first group, second group, third group, then group 13 to 18, then 4 to 12. We are going to see the general outer electronic configuration in group 1, 2 and 3. That is your table 7.1 and 13 to 18 group. Here for group number 1, 2 and 3. What is the rule student? Group 1, 2 and 3 state that the general outer electronic configuration will be same. Fine. So here NS1. Let's see an example over here. Lithium, atomic number 3. Its electronic configuration is 1s1, 2s, 1s2, 2s1. Here we are writing down only the general outer electronic configuration. Fine. So 1s2, leave it aside, 2s1. Then sodium, it's belong to third period. and first group, so its general outer electronic configuration is PS1. Let's move. Here some of the example has been given. Not all the elements of the periodic table electronic configuration has been given. Some of the elements has been taken out and they have given as an example. We're supposed to solve it. For group 2, its general outer electronic configuration is Ns2. Be beryllium atomic number 4. Its general outer electronic configuration is 2s2. Then the another example is magnesium. Atomic number is 12. General outer electronic configuration is 3s2. For group 3, Ns2 n-1 d1. Okay, as group 3 elements belongs to D block. So here the example has been given. Scandium atomic number 21, 4s2 3d1. For group 13, Ns2 np1 is general outer configuration. Let's see one example over here. Boron atomic number 5. General outer electronic configuration is 2s2 2p2. 2s2 2p1. Then aluminium atomic number 13. Its general outer electronic configuration is 3s2 3p1. Now for group 14, its general outer configuration. For group 14, its general outer configuration is Ns2 np2. Let's say an example over here. Carbon atomic number 6. Its general outer electronic configuration is 2s2 2p2. While for silicon atomic number is 14. Its outer electronic configuration is 3s2 3p2. We are moving forward towards group 15. Its general outer configuration is Ns2 np3. Let's see an example over here. For nitrogen atomic number 7, its outer electronic configuration is 2s2 2p3, as nitrogen belongs to second period. Okay, and group 15, so 2 number of shell are present over here. Another example, phosphorus atomic number 15, its outer electronic configuration is 3s2 3p3. Then group 16, general outer electronic configuration is Ns2 np4. Let's see an example over here. Oxygen atomic number 8, its outer electronic configuration is 2s2 2p4. Another example, sulfur atomic number 16, outer electronic configuration is 3s2 3p4. We are moving forward towards group 17. General outer electronic configuration is Ns2 np5. Fine, Ns2 np5. The example for the same is fluorine atomic number 9, 2s2 2p5. Another example, fluorine atomic number 17, its outer electronic configuration is 3s2 3p5. Then group 18, its general outer electronic configuration is Ns2 np6. These are group noble gas elements. Here example for the same, neon atomic number 10, outer electronic configuration is 2s2 2p6. While argon atomic number 18, its outer electronic configuration is 3s2 3p6. Fine. In this way, students, that the table has been given for group 1, 2 and 3 and group 13 to 18. You see, in group 13 to 18, Ns2 is there, fine, is common in all of the group, and then NP1 is, we are moving down, you will see NP1 has been converted into NP2, NP3, NP4, NP5 and NP6. In this way, you are going to write down the general outer configuration of the respective group which has been given in your textbook and some of the example of it, and you are going to write down the outer electronic configuration of this example. We have studied this and this too for group 1 and group 2 element. In this way, you are going to write down the electronic configuration of the elements in the group. I am repeating it again, student. If you know the Obve principle very well, you can write down the electronic configuration of any of the elements of the periodic table. If you find any difficult in Obve principle, see our previous lecture, study it well, and your all the doubt will be clear. Inshallah, hope you all have understood. Try it. Write down the electronic configuration of the elements. Once these all things will be clear, you will be expert in this. Okay, student. If you have any doubt further, let me know. Inshallah, all the doubts will be clear. Till then, take care. Study well. Do your best. Thank you.